First step, please. Yes. So I have 4x squared minus 12x plus 8 that I have to factor. It's in descending order. It's not a special product, but I can factor out 4, and I will. So it's x squared minus 3x plus 2. And now this is so much easier to factor. So this is 4, oops, x minus 1, x minus 2. So this is done. Now the other one. 3x squared minus 6x. I factor out 2x, and I get x minus 2. So now I go back and rewrite the whole thing as 5 over 4 x minus 1, x minus 2 minus 3 over 2x, x minus 2. How many restrictions do I have to write? Let's go from left to right. What is the first restriction I have to write? Second restriction. And I have an x as a factor, 0. Very good. So 3 restrictions. Excellent. Now I have to find the least common denominator. How many different factors? And remember, 2 and 4, so 4 can be rewritten as 2 squared. So how many different factors I see here?
1.
How many?
1. No,
Different factors.
So it would just be 2.
Different factors. I see 2, I see x minus 1, I see x minus 2, and I see x. 4 different factors I see.
How did you factor out 3 divided by 3x squared minus 6x?
I thought, I'm sorry. I meant 3, but I wrote 2. And I don't need this now. Thank you. Thank you. Very good. So now I have 1, 2, 3, 4, 5 factors. 1, 2, 3, 4, 5. 5 different factors. So then the least common denominator is 12x, x minus 1, x minus 2. All different factors have to be present in the LCD.
I factored my denominator for the 1 and the 5 differently.
Which one?
Yeah, that one.
Okay, I'm going to write what you wrote.
The 2x minus 2 minus 2x minus 4.
2x minus?
4.
Right. So I have to factor out a 2 from here. I have to factor out a 2 from here. So then I have 4 times x minus 1, x minus 2. That's why this first step in the strategy of factoring, I say, is it in descending order? Is there a greatest common factor? Is there a negative leading coefficient? I have to pull it out. Because your factorization is not fully simplified, fully factored. And then you will even get more factors in the denominator if you don't do. Okay, good. Is it clear? So 4 is a factor, 3 is a factor, x is a factor, x minus 1 is a factor, and x minus 2 is a factor. Do we agree with the least common denominator? Okay, because if you don't get the correct least common denominator, you will never find the correct adjustments. So the top of these two will be totally different. So what is missing from here? X minus 1 and x minus 2 are here. A 4 is in the 12. So what is left that I need to multiply the top by? So these are here. Exactly. 3x. Now let's look at the other one. X minus 2 is here. X is here. These are here. A 3 from the 12 is here. So these two are here. 4. Exactly. So 4 quantity x minus 1. So now let's write the numerator. First we have 3x times 5, which is very good. Now I have to be careful because it's negative 3 times 4 times x minus 1. But negative 3 times 4 is negative 12. Negative 12 times 4 is negative 12x. And negative 12 times negative 1 is positive 12. We combine our terms, and we get 3x plus 12, everything over 12x, x minus 1, x minus 2. The only thing I would do is what?
Include 3x.
Right. Even if I see that I cannot take it anywhere else. However, actually I do, because I can simplify the 3 with the 12. So it is crucial to do that. So then the simplified form is x plus 4 over 4x, x minus 1, x minus 2, of course assuming these conditions are fulfilled. So they can get hairy, right? They can be cumbersome. It's a lot of work. Okay, let me know if we need another.
Yes.
Okay, very good. The more we see this, the better we get at adding and subtracting. Would you agree?
Yes.
Okay. Okay, here's another messy one. 78. 8 over x squared plus 6x plus 5 minus 3x over x squared plus 4x minus 5 plus 2 over x squared minus 1. 3 minutes. What will you do first? Of course, because otherwise you can't find the least common denominator. Can anyone give us anything?
The first.
Yes?
X plus 5 times x plus 4.
Do we all agree with x plus 5 times x plus 1 on the first one? Okay, the second one.
X plus 5, x minus 1.
Do we all agree with x plus 5 times x minus 1? And the last one.
Doesn't it just stay the same?
Careful, it's the difference of squares. Please redo the strategy factoring. Strategy of factoring the binomial. Special product, difference of squares. How many restrictions will you give?
No.
Yes,
X
So-
can't be negative 1.
correct?
It can't be 1
Yes,
or negative.
excellent. So, saying that, you will give me now the least common denominator, which is
x plus 5 times x minus 1 plus, times x plus 1.
Excellent. Can anyone give us the adjustments at the top of every fraction?
For the first one, it's x minus 1,
Exactly.
then x plus 1,
Exactly.
then x plus 5.
Exactly. When you have the numerator ready, I'll put it in. Ready?
With the simplified version or all the numbers?
All for everyone to see.
8x minus 8
Perfect.
plus 3x squared.
Careful.
Oh, minus 3x squared.
Then,
Plus 3x
careful.
minus 3.
Yes, the minus in front of a fraction gets distributed to all terms that come to the top. Gets distributed to the top to all terms from that fraction. Not the next fraction, but all of those at the top of that fraction. So then minus 3x. And then?
Plus 2x
And then plus.
plus 2.
I agree. And now in descending order, please.
So, negative 3x squared.
Yes.
7x.
Very good. Positive 7x
2.
plus 2. What will you factor out now at the top, even if eventually or
The
potentially?
negative.
Yes. I will put negative 1 in front of the fraction line and I will write 3x squared minus 7x minus 2. I will try and check if you want to see if I can factor this. So the product is negative 6 and the sum is negative 7. So if the product is negative 6, one has to be positive, one has to be negative. I can never find two numbers whose product is negative 6 and whose sum is negative 7. So this is it. But at least I tried. So this is the simplified form, assuming conditions are fulfilled. I would like to move on to 7.5 because this is basically the same thing. Just a slight difference, or addition, I should say, not difference. Slight difference to what we've, addition to what we've just worked on. Okay, this is section 7.5. Solving. What do you think? Rational? If I said solving rational, what should follow? That's true, but in this case, it's going to be just equations. But you're right. You're right. We can do that too. But in this chapter, we only look at rational equations. So I'm going to solve one, maybe two, whatever you want me to do. And then you're going to work on a couple of problems. But I want you to watch first, okay? Then I'll give you time to copy. There are two types of rational equations. One that is easier than the other. One is called proportion. And the other one, not a proportion. So you can write this down. I would like you to have this. And then we'll choose from the proportions, and then we'll choose from not a proportion. Of course, proportions are easier. So how do I deal with a proportion? There is only one thing that I can do in a proportion. So A over B equals C over D. This is an example of a proportion. A fraction, one fraction on the left, equal symbol, and one fraction on the right, and nothing else. So what can I do in a proportion that I cannot do in anything else? Excellent. So then I will do this. If this is correct, then A times D must be B times C. A times D must equal B times C. So let's look at a few examples with proportions. On page 480. Let's start with problem 27. A divided by a minus 6 equals negative 2 divided by a minus 1. Is this a proportion? It's definitely a rational equation because it has the variable in the denominator. But is it a proportion?
Yes.
Yes. I have to state how many restrictions. It has to be before. So a cannot equal,
1.
we're right, and a cannot equal. Perfect. Only after I state restrictions, I can proceed to cross multiply. What should I write?
It's
A squared
Yes.
A.
Very good. When I multiply these two, I get a squared minus a. I agree. Equals?
Negative 2a plus 12.
Excellent. So when we cross multiply, we get indeed a squared minus a equals negative 2a plus 12. In agreement or disagreement? Do we agree? Good. Now I look at this equation, I say, I know how to solve this. What is it? Excellent. How do I solve a quadratic equation? Very good. So then I have a squared, I bring a positive 2a, and I bring a negative 12. So in other words, I added 2a to both sides, and I subtracted 12 from both sides. Do we agree that we get a squared plus a minus 12? Okay, now I look at this, and I say, okay, it's a trinomial, it's in descending order, no greatest common factor, no negative leading coefficient, 1 is the leading coefficient, no special product. What do I do?
A plus 1.
A plus.
Two.
Product is negative 12, sum is positive 1.
3.
It's 43.
We're getting there. We started with 1. So A equals? A equals.
Negative 4 and plus 1.
Are these among the restrictions? Are they among the list of no's? No. So I'll say yes and yes. That's the main purpose of restrictions, of stating restrictions.
What if they are?
Then I'll say no solutions. Or I will say I will cross one of them out. Who knows? I don't know. In this case, 3 and negative 4 are not on the list. They're both solutions. Okay, perfect. Next problem, let's say 35. T over t minus 4 equals t plus 4 divided by 6. 1 minute. Okay, 2. Do we need more time? First step, please. Careful. First step.
Oh, you state restrictions.
Yes, because I can no longer state restrictions after that. It's too late. So t does not equal 4. Good. Now I cross multiply.
It's only the denominator as well.
Yes, only the denominator, of course. The numerator can be anything. A fraction is undefined only if the denominator is 0. The numerator can be anything. Good. So then we get,
6t
very good, equals,
t squared minus 6t.
very good, right? Because we know that t minus 4 times t plus 4 is t squared minus 16. Good. What type of equation is this? Good. So then I have t squared minus 6t minus 16 equals 0. And then, good.
I got t plus 2.
Very good.
T plus 8.
Minus 8.
T minus 8.
Good. So there are two options. T equals negative 2 or t equals
Negative. 8.
8. So are these on the list of restrictions? No. So yes and yes. Did we get the idea about proportions? Can we move on to the real thing now? Okay. It's not difficult now. I consider this the second most difficult topic in this class. But once we understand 7.4, how to add and subtract rational expressions, the rest will be not difficult. Okay. So I'm going to start with 39 on page 480. For r, let me put x. 4x minus 4 divided by x squared plus 5x minus 14 plus 2 over x plus 7 equals 1 over x minus 2. Now, we know that and we see that this is an equation, right? It has the left-hand side, it has the equal symbol, it has the right-hand side. Similarly, it's not the same thing because it's a different type of equation, but similar to what we just did here, we moved everything to one side and we set it equal to 0. I will apply the same idea. It's a different type of equation, but I will apply the same idea. I want this term to be on this side and I want to have 0 on the left. I'm sorry, on the right. So then I copy the top as 4x minus 4, and right now, because I don't want to write it one more time, I want to factor the denominator. Can anyone factor the denominator for us?
7 and 2. Or
X.
negative 2.
X plus 7, x minus 2, I agree, plus 2 over x plus 7, and then can anyone tell us what to write next?
Minus.
Very good.
whatever.
Exactly. Then you will give me two restrictions, because I see two different factors in the denominator. And
2
there
and
is
negative 7.
very good. 2 and negative 7. So therefore, now look what I did. I drew a long fraction line, then the equal symbol, and then 0, because if I forget this side with 0, I will never solve for anything. I will change it into an expression, and I will never get x. So equal symbol and 0. Now please give me the least common denominator.
X plus 7, X minus 2.
Adjustments for the top.
You just multiply the first one by 1. The next one by x minus 2. And then the last one by x plus 2.
Good. So now what do we have at the top?
4x minus 4. 2x minus 4. And
X
minus
minus
x minus 7.
Because it's negative 1 times x and negative 1 times 7. Very good. What will be the next step? So nothing is new here. The only thing that is new is that I moved the term and I have 0 on the other side. But from what we've studied so far tonight, right, exactly. So I have to solve. So then, top. Perfect.
minus,
Yes?
no, wait, minus 15.
Very good. Now, here's a question for you. At this point, I just have a quick question. Can I write 5 as 5 over 1? Can I replace, if I want to, 5 by 5 over 1?
We could.
If I want to replace 13 by 13 over 1, can I do that?
Yes.
Can I replace 0 by 0 over 1?
Yeah.
Yeah.
Yeah, good. That's what I'm going to do because this will tell you something. So if I write the right-hand side as 0 over 1, that should ring a bell and say, oh, I know. Now you change this whole thing into a
Proportion.
exactly. How do I deal with the proportion?
Let's find out what the, what is it called? Limitation? Oh, wait, you crossed one.
We already stated restrictions right here,
Oh.
way long ago. So then I have 5x minus 15 equals,
Zero.
okay, or 5x equals 15 because this is not quadratic, this is linear. So then x equals,
5.
one more time,
Negative 5.
one more time.
3.
Good.
No.
Is this on the list of restrictions? No. Any questions? Any questions? Okay, 37. 37 is for you. On 480. Y over 2y plus 2 plus 2y minus 16 over 4y plus 4 equals 2y minus 3 over y plus 1. 3 minutes. Can anyone just list the steps? Just list the steps for me. Step 1.
So that equals 0.
Yes. If you want that step to be 1, that's fine. Step 2.
Factor.
The
If-
denominators. Excellent. Step 3.
List what it can't be.
Yes, state restrictions. Step 4.
Then you multiply
Find
the least common.
the least common denominator. Step 5.
Then you multiply the top.
The adjustments at the top. Step 6.
Simplify.
Combine like terms, indeed. Step 7. It's already into proportion. Put 1 over 0
Yeah.
over 1 and then cross
Yeah,
multiply.
close
Look at how many steps. We really test the entire course in one problem, almost.
Like
Okay?
I said, the final exam could just be one problem, pretty much.
Well,
It could be.
If you
Okay.
got it wrong, that would suck.
Yeah. It's a 100-point problem.
Now, I have to say one more thing. For the student who is capable of solving this equation, that student should say, I acquired algebra skills in this class. Because if you know how to do that, you will be able to do anything else in this course. So next semester, you're going to come and teach, and I'm going to sit down and watch. I mean, it took us 3 minutes to list the steps, not do them, just list them in this problem. So you have 4 from here, right?
Yeah.
That's 2 times y is not 4, 1, right?
Right.
Can we start this or not yet? So as the first step, can anyone dictate, please? So I have y over
2 plus 1
times y plus 1 plus 2y minus 16 over
4 times 5
minus
2y minus 3.
over y plus 1 equals. The only restriction I have to write is
Negative 1.
perfect. Now I need the LCD.
4 plus 1.
I have to look at all different. See, let's write this. Let's mimic this. Okay, just pay attention for 1 second. If I choose this as the least common denominator, when I say this times what is this, I will not have an answer.
Is it 8
It's
times
4.
It's 4, right? Because this is 2 squared. So 4 times y plus 1. Now this is correct. And now when I say this times what is this, I have an answer. And the answer is
That's 2.
2. This times what is this is 1. And this times what is this is 4.
So it's 2y.
Yes?
2y minus 16 minus 8y plus 12. Yes.
Very good. Perfect. Next step.
Negative 4y minus 4.
Over.
4y plus 1.
Since I'm in a proportion setup right now,
0 over 1.
right.
Okay, and then you get negative 4y minus 4 plus 0.
So negative 4y, because it's linear, I have to,
Equals 4.
yes, which means y equals,
Negative 4. Right, so it's negative 1.
right? 4 over negative 4.
Funny. So there's no solution.
See now how important the restrictions are? Okay, next problem. Let's work on 41. Do you have any questions on this problem on 37? Any questions on 37? Okay. 41. X plus 1 over x plus 3 equals x squared minus 11x, everything divided by x squared plus x minus 6, and minus x minus 3 over x minus 2. Yes, you could move this here. I recommend keep everything on the left-hand side and move these two here. It's not going to hurt if you move two terms and set equal to 0.
I mean, really, if you move it over there, can't you just, to your eyes, just put that on the
That's
left?
fine. It's fine. So you could take this one here and say minus that equals 0.
Yeah.
Absolutely. I agree.